In most mechanical designs, weight reduction does not fail because of engineering capabilities. It fails because engineers rarely have the time to explore multiple different design options. So what usually happens is we design one safe plate, add a margin and move on. But what if the software could try those options for us automatically and tell us which one actually works the best? And that's what design study is used for. I am Dwarkesh, application engineer, will be showcasing design study using SOLIDWORKS Simulation. This is a grabber assembly used for lifting and handling loads. From the full assembly, I have focused only on the mounting plate for study. This plate is critical. It transfers load from the grabber to the structure, and at the same time, it contributes significantly to the overall mass. This makes it a good candidate for optimization. In a traditional workflow, an engineer would manually modify design, increase hole diameter, run simulation, reduce thickness, run simulation again. This repeats for multiple iterations until time runs out. This is slow and is heavily dependent on experience. For example, making 20 to 30 design changes manually could take several days, whereas a design study can evaluate the same iteration in just minutes. With a design study, SOLIDWORKS does this automatically. The engineer defines the rules and the software explores the design space. Here, I have set up a design study inside SOLIDWORKS Simulation after completing a static analysis. The design variables considered are hole diameter, plate thickness. These are practical parameters, easy to manufacture and control. The primary constraint applied is a minimum factor of safety of 1. This ensures that every design iteration evaluated by the software remains structurally safe. The objective is straightforward: minimize the mass of mounting plate. So the study is not guessing, it is constantly checking. Is it safe? If yes, can it be made later? SOLIDWORKS evaluates multiple design combinations automatically. From those, it identifies the configuration that achieves the lowest possible mass while still meeting the factor of safety requirement. What's important is that this result is data driven, not intuition based. The stress and displacement are within limits and material is removed only where structurally not needed. From an organization perspective, the result is clear. Reduced material means lower raw material costs, lower weight, improves handling and reduces load on mating components. And because this is digitally validated, the number of physical prototypes are reduced. By automating the exploration of multiple design alternatives, engineers are free to focus on higher value tasks instead of manually evaluating iterations. All of this shortens the design cycle and saves costs. So instead of designing one safe plate and stopping there, we let SOLIDWORKS Simulation explore multiple safe designs for us. That's how our design optimization becomes practical and not theoretical. This summarizes how a design study enhances the simulation process in SOLIDWORKS.